Hey guys, today we're going to continue on with our transformations unit. Last time we talked about reflections. This time we'll talk about translations. Okay, so a similar thing, but a few things that are different. Okay, so a translation, you're going to write the definition down. A translation is a transformation in which all points a transformation in which all points move the same distance and same direction. Along a vector. Okay, so a translation is a transformation in which all points move the same distance and same direction along a vector. Okay, so make sure the two things that you know for sure, they move the same distance. Okay, so underline that. Same distance and same direction. Okay, so those are the two key points that you need to be able to know from that definition. All right. Okay, so a couple of examples. It wants you to tell whether each transformation appears to be a translation. Okay? So the first one, it looks like you have a line of reflection, and it looks like it's reflected. So no, this isn't a translation. This is a reflection. Hey, but what about the other guy? It looks like each point is moved the same distance and the same direction. So it looks like it should be a translation. So yes, is a translation. All right, so your next definition you need to know is a translation is a transformation along a vector. Each segment joining a point in its image has, blanks should be same length as a vector. Okay, so same length as a vector and parallel to vector. Okay, so a translation is a transformation along a vector. Each segment joining a point in its image has same length as a vector, and it should be parallel to a vector. Now, a vector isn't a word that you're probably familiar with, okay, but it's similar to an ordered pair. Okay? But a vector is always going to be in this form. Okay? It's going to be inside of these brackets, and you're going to have a x and a y. Okay? So if you had an example vector, you could say 2, 3. That 2 represents the change in x, and the 3 represents the change in y. Okay, so you need to be aware of what a vector means. Okay, so let's look at an example real quick. It says translate the triangle with vertices, those 3 vertices, along the vector 3, -1. So what that means is you're going to translate each of those ordered pairs to this vector. And what that means is that each ordered pair, the x, you will go 3 to the right, and then for each y value, you will go 1, -1 down. Okay? So let's go ahead and graph each of these ordered pairs that it gives us. It gives us -3, -1. There's your first ordered pair. Then it gives us the ordered pair 5, -3. 1, 2, 3, 4, 5, and then down 3. And then lastly, it gives us -2, -2. Okay, so here is our little shape. Okay, and it wants us to translate that shape along this vector. Okay, so each ordered pair, we're going to take the x and we're going to go right 3, and then we're going to go 1 down. So we started with -3, -1. Okay, so if we follow our vector, we have to go 3 to the right for the x, so that means add 3 to it. So if you take -3 and add 3, you get 0. And if you take -1 and subtract 1 away from it, that would give you a -2. Okay, so that would be our first ordered pair that we're going to graph for our translation. A second one, we had 5, -3. And we're going to add 3 to our x and take 1 away from our y. So if we add 3 to the x, that of course gives us 8. And if we take 1 away from the y, that gives us -4. And lastly, -2, -2. Going to add 3 to the y, or x, and then we're going to take 1 away from the y. So that would give us 1, -3. And so let's go ahead and graph our points. So we have 0, -2, and I'm going to do these in red. Okay, 0, -2. Then we have 8, -4. 1, 2, 3, 4, 5, 6, 7, 8. And down 4. And lastly, we have 1, -3. Okay, so if we go ahead and draw our lines, that would give us our translated shape. It moved in the same direction and the same distance with our vector that we applied to it. Okay, so make sure you have these notes down. Very important that you have it down and have the concepts. We're going to try a few more on the next page. Okay, before we move on, I have a quick dumb joke for you. In every town, what building is always the largest? Think about it. Think about it. The library, because it has the most stories. You like it. All right. It says, translate the quadrilateral with vertices 2, 5, 0, 2, 1, -1, and 0, or 3, 1. So let's go ahead and graph those points. And we have 2, 5, 1, 2, 3, 4, 5. We have 0, 2. We have 1, -1. And lastly, we have 3, 1. Okay, so there's our quadrilateral. And we want to go ahead and translate that along this vector. So we need to go ahead and take 3 away from the x and take 3 away from the y. Okay, so let's start with each of our ordered pairs. We have 2, 5, 0, 2, 1, -1, and 3, 1. And we're going to add or subtract 3 from the x and subtract 3 from the y on each of those. And if we do that on each ordered pair, you're going to get, for this one, -1, 2. Then you'll get -3, -1. -2, -4. And lastly, you will get 0, -2. Okay, so definitely take some time to go back through and make sure you understand that from the x you're taking away 3 and the y you're taking away 3, and that's how I get my new ordered pairs. Okay, so now we need to go ahead and graph those ordered pairs. And I'm going to do this in red. So we have -1, 2 as an ordered pair. We have -3, -1. We have -2, -4. And lastly, we have 0, -2. Okay, so you can see that if you join your lines, you have a quadrilateral that is moved in the same direction along the same vector, and that has resulted in its translation. Okay, let's try a couple more examples and then we'll call it good for the day. All right, it says a sailboat has coordinates 100 degrees west and 5 degrees south. The boat sails 50 degrees due west, then the boat sails 10 degrees due south. What is the boat's final position, and what single translation vector moves it to get to that position? Well, when you have these word problems, you're going to want to establish a vector, and sometimes a picture can help us. So let's draw a compass rose. We have north, east, south, and west. And you're going to want to draw or write a vector that represents the initial location of the sailboat. Okay, so we have our location here. Right now it says the coordinates are 100 degrees west. So on our graph, if you go 100 degrees west, that would give you a negative 100 in your x direction. And if we go 5 degrees south from there, that would also be a negative number, which would be negative 5. Okay, so that is our current location of our boat. Okay, then it says our boat sails 50 degrees west and 10 degrees south. So if it moves in the vector negative 50, negative 10, that tells us that we need to take away 50 from the x and take away 10 from the y. So if we take negative 100 minus 50, that of course gives us negative 150. And if we take 10 away from y, negative 5 minus 10 is negative 15. Okay, so that is the new location of the boat. So if you wanted to write that in terms of direction, you could say that the boat was in the final position of 150 degrees, let's zoom in here, 150 degrees west, and then 15 degrees south. Okay, so that would be your final solution for that particular problem. Okay, so let's go ahead and try one more, then we'll be done. It says, a rook on a chessboard has coordinates 3, 4. The rook is moved up 2 spaces, then it is moved 3 spaces to the left. What is the rook's final position? Okay, so we know that its initial position, was 3, 4, and then it moved in the vector 3, or moved up 2, and then it moved 3 spaces to the left. Okay, so there's your vector that you are given. So we know that we need to add 2 to the x-coordinate and take 3 away from the y-coordinate to get our solution. Actually, let's think of this again. Okay, it says the rook is moved up 2 spaces, and it's moved 3 spaces to the left. Okay, so your 2 is actually moving in the y direction. Your negative 3 is moving in the x direction. So those are what we're going to have to take. We're going to have to take these 2 together and these 2. And so if we, excuse me, sorry, I'm botching this. Give me just a second. Okay, we know that these guys should go together, the x's and the y's should go together. Okay, so if we take 3 plus negative 3, that would give us 0. And then if we add the y's together, 4 plus 2 gives us 6. Okay, so our location would be 0, 6. Another way to think of it is if you graphed it, you have the location 3, 4. Okay, so there's our initial location. Then it says we go up 2 spaces, and then we move 2 spaces to the left. Okay, so it ends up being at the location 0, 6. Okay, so that's another way to think about it. Okay, so here's just a few examples of what we're playing with today. Your homework will be a little easier than what we've just done, so hopefully it'll go okay. See ya.